Hello everyone. Our topic of presentation is preventive approaches against the worst cases scenario in software systems. And these are the topics which we will cover in our video. So we will start our presentation with some worst case examples in software systems. So our first example is about the Ariane 5 rocket which was launched in 1996. Ariane 5 rocket was crashed and failed to achieve its orbit due to an exception in software which was caused by assertion having turned off. In Ariane 5 rocket, the working code of Ariane 4 rocket was reused, but due to greater horizontal acceleration, an exception occurred in a code which was responsible for converting 64-bit floating point number into 16-bit signed integer, and that caused the destruction of the flight and crashing. And another popular example is ping of death, which is also known as long ICMP attack. The ping of death is an DOS-based attack. Normally the size of a ping message is 56 bytes, but historically many computer systems could not handle a ping packet larger than 64 kilobytes, which is the size of IPv4 packet. But then attacker found that the packet broken down into fragment could add up to more than allowed 64 kilobyte, and when computer receive an oversized packet, then they don't know what to do with these packets, and that results in the frozen of computer or crash or rebooting. So we can see that a small system bug can result in a disaster. And so these are some possible causes of worst cases condition. First is dependency, requirement issue, management issue, and lack of knowledge, or some other critical issue like unavailability of testing facility or unachievable performance requirement. So now we will discuss the prevention mechanism one by one. Let us start with the prevention mechanism for the typical scenario of buffer overflow and stack smash. So what is buffer overflow? Suppose we have some input data and we have to store it on some memory location, but the length of input data exceeds the length of allocated memory, then it will lead to a buffer overflow. So now what happen if a buffer overflow? If a buffer overflow, then it may overwrite the system data or the user data, or it may active an attack. Okay. So how to prevent from it? So our first choice is by using the non-executable stack, that is NX bit, or we can use safe languages like Java and C Sharp, or by using the more safer C function, for example strncpy instead of str. Now stack smashing prevention by using the canary method. So what is canary? A canary is a constant value which is placed between the stack and the user data. So if any overflow of a local variable will occur, then it will damage the canary value first. So thus we can prevent the stack overflow. Now the next prevention mechanism is runtime checking by using the safe libraries. Basically, it checks the program error at runtime. So these are the dynamically loaded libraries. For example, a call to strncpy method will check if there is sufficient space in current stack frame. If there is sufficient space, then it will perform the copy operation, or else it will terminate the application as shown in figure. Now the next preventive mechanism is purify. Purify is a memory debugger program to detect the memory access error in a program. For example, violation of array bounds, or use of uninitialized variable, etc. These errors are often caused by passing incorrect argument to the library calls, or by misunderstanding about the protocol for freeing data structure. In this method, a special instruction inserted before each load and store operation which detect all the runtime error and memory leaks. Now the most important prevention mechanism, that is encrypting pointer in memory. In this method, the attacker overflow a function pointer so that it can point to an attacker code. The basic idea is that we encrypt all pointers that are in memory. For this, we generate a random key, and we XOR all the pointer with that random key to encrypt this pointer. So the profit of this encryption is if that the attacker cannot predict the target program's key, even if the pointer is overwritten. Then after XORing the key with it, it will dereference to a random memory address. Uh, Now from this diagram, we can see that a normal pointer can be overridden and it can lead to an attacker code, while while in the case of encrypted pointer, it will prevent from this situation. Now the next prevention approach is input validation. Input validation is the most useful mechanism for web services. Consider a web form data. Suppose the input is validated only on client side. Then, for example, this URL in this URL, the client send the value of the argument total is 205. But in between, the attacker attacked on this URL and changed the value of total from 205 to 225. And at the server side, if the server accepts that value without any validation, then it could be disastrous. Thus, there is a need to validate input on both sides, both client and server side. Thank you.